only one that has not been made in the list.
Mm.
All the rest has already been made or very difficult to play with.
Can you check to the right here? Can you go to the data and look on the right side? What else is the information there?
Oh, it's
So
just something I extracted the lattice informations.
this
Apart
is
from that, nothing.
already, this is in materials project, right?
This is
And
from the materials project.
these are lattice sites. So I think one thing, of course, we have to check is if the lattice constants that the after relaxation that Masato and stuff get is similar to this or not. So maybe it's just make sure that it is, right? But if there's no other
Yes.
structure in this composition, that's a good news, right? It's very good.
Oh no, so it's actually pretty far away from the next point. So we probably will use the next point as a precursor, but the difficulty of making this compound depends on whether we are able to make the precursor we want, something like that. Because we did a preliminary research, we cannot buy it.
Mm-hmm. So,
Oh, so you have to make the precursors also.
Yeah. Let me show you the phase diagram. Uh, A Y O.
I'm not seeing the. Uh, okay, I got it.
Yeah, so this is the target phase. And what you can see
Mm.
is that it's basically the only two phase inside, and this is a metastable phase. So it's 80 millieV above the hole. And the bad synthesis route is apparently we need to get something like this KYO2. Of course, we need to run the reaction network to see what other precursors are there, like chlorides, the sort of thing. But if within this ternary phase diagram is this, um, I think, Kara, you know that if we run reaction network, you will suggest more funny precursors. That's true.
Yeah, yeah. And we can do the meta thesis as well, right? Like
Yeah,
this is
yeah,
what
yeah.
we did. And we can look at there are these possibilities where you introduce things like because the simplest example is that if you introduce something like a sodium-based oxide that
Yeah.
then oxidizes out the equation, it becomes a salt and goes away, which you can dissolve, right? Then, but it facilitates the
Um,
energetic reaction. Then you can add these salts to facilitate the reaction, and then it becomes more feasible. These kind of things can be considered in the reaction network. So
uh,
what Ivan is.
uh, uh, Sorry, Kara, I think I lost you. Maybe my internet is a bit slow.
Is it my internet or can everybody else hear it? Because I'm sitting outside a cafe. It's possible my
Uh,
internet is bad.
I hear you clearly.
Okay. So yeah,
Oh,
it's just
then probably
basically
my internet.
anyway, I think Ivan, you already know this. Like it's just the metathesis is the alternate reaction pathway. Okay, let's put it that way.
Yeah.
We don't need to go into the
Okay.
details.
Yeah, sure.
So this
So this
compound will depend upon whether we're able to synthesize the precursors, right?
and not just this. The reason I'm not super keen on this compound is that although you see it's on the whole surface, right? So if I use this dot and this dot, so basically K2O and KYO2, if I assume they form the whole surface, and this point is only like about tens of MeV below the hole.
Mm-hmm.
So it's like very shallow in the hole.
I see.
You got what I mean, right?
Yeah,
So
yeah,
some of the compound they are all they're whole compound, but they're not necessarily easy to access kinetically.
yeah.
So if I just convert the diagram to 3D, and you can easily see that that's almost a straight line.
Yeah,
So from that to point, so it's basically something just on the whole,
yeah.
or maybe in the range of DFT accuracy, these sort of things. It's almost a
Got it.
straight line here.
Mhm.
Mm.
So this is the point. If you see that, and from whichever angle you look at it, it's basically a straight line.
Mm.
Yeah,
Okay, so maybe you should write a note that this is the way we proceed, right? Can you
yeah,
write a note on the Excel sheet
yeah,
and maybe on WhatsApp or something after
yeah,
this with
yeah,
pros and cons, right? So we say good news is there's nothing that is locally, there are no competing compounds and no
yeah,
disordered compounds in ICSD.
Yeah.
right? So we write those notes, and I think it's better to put in
Yeah.
the Excel sheet so we can then
Sure.
share this with others, right? So just in the column at the end, just make a remark and say these are the pros and cons, right? So there's no
Yeah.
good news, there's no competing crystalline or disordered phases.
Mm-hmm.
Bad news is that it's only around 10 MeV per atom below the
Yeah.
hull,
Yeah.
and the precursors might be difficult to obtain.
Yeah.
So, and it's an oxide.
So
For me, I prefer DGS is a direct route, which is better
yeah.
than oxide is hard to DGS. Simple.
Yeah.
So can you
But
just make
aside from, yeah,
yeah, go
please.
ahead.
Yeah.
Yeah, I'm just asking Haiwen this question. Like, aside
Mm.
from just synthesizing the things that we never synthesized, we also could
Yeah.
synthesize the things that has been synthesized before but never measured the thermal conductivity, right? Which is the PRTE.
Yeah, of course. I mean, I think it's possible.
Mhm.
So I mean,
I think the first, yeah.
the only thing is, if you think about the priority, it would be what has not been made before, and then the low thermal conductivity, and then of course things have been made before, but with no measurement of thermal conductivity, we can do that.
Yeah.
Anyway, we
So,
choose one or two. It doesn't matter,
mhm.
So then, how about in the meanwhile, I just run the reaction network for this one first
Okay.
and see what are the paths we get, and we can have a discuss about like the first 5 or first 10 paths a bit later and think about how we can approach it.
Okay.
Maybe we want to choose another one from the list of greens. So the list of greens are something I have confirmed. They are references I have read through. I compared the seed files in the atom by atom. I confirmed that either the exact structure or the structure, a slightly disordered version of the structure had been made, but there's no thermal conductivity measurement. So there are 3 green ones here plus 2 green ones here. So the first green one is PR2TE3. There is another one PR2SC3. There is another one is this BAPRSC2 bracket 2. And we have another one is K2SNTE5 and BAGE04. So they're in total like 5.
Should we pick 1 or 2 out of these 5?
I mean, it's up to you guys. What I can do is I tell you what are the phases has been made and there are literature references that tell you how to make them.
So sorry, what does the green mean again?
The green means that I can find experimental reports making this exact compound,
Okay. And the structure
but
match,
without thermal conductivity measurement. Sorry.
but it matches the same space group or not?
I mean, I check the C file atom by atom.
Okay, but does it
So the
match?
C file, they match. The only thing is this one, and this one. So materials project for calculation, they use an ordered version of the sieve, but experimentally it's a disordered version. So I have no idea how different they can be in thermal conductivity measurement. So I think it's this one, and this one, but maybe I'm wrong. I need to go back and check my raw data. So, and what's confirmed, it's exactly the same as this one. K2SNTE5. It's exactly the same as yeah.
So this is like not really found in SSD, but you found it from another database, right? The X, what's the PDF? Which database did you find, Helen?
Literature,
I think
right?
we lost it.
Look at this in literature. Ivan's frozen, I think.
Yeah. Yeah, I think I'm just thinking like
It's
putting
basically the database we are comparing to ICSD is a sorry, let me just switch my network.
yeah. I'm just thinking about a more streamlined version, like
I mean in
SSD.
NTU.
SSD apparently is not that that comprehensive. Yeah.
I mean, we would have to check before we make any of these, we have to check rigorously in literature. There's only one or two compounds, right?
Yeah.
So
So
today
currently,
we shortlist to 2 or 3, and then we do a final rigorous literature check
yeah.
and okay, we want to try this. This is what like Jayanta and his group would do. This is where you guys can come in.
So yes, yeah.
But I'm
So
thinking
all these
about how can we
compounds,
automate? Yeah.
Wait, Danny?
Yes, Ivan.
I mean,
Yeah.
automate is easy. Just buy a PDF database license because ICSD is not so comprehensive. All
PDF,
those green
right?
compound here, yeah, are the ones that ICSD misses, but PDF has the seed file with the references.
Interesting. Okay.
I mean, let's discuss the potassium compound, potassium tin telluride, and let's do pros and cons. I would like I have to drop off soon, but can you guys please go through each green compound, all of them, 9 of them, and do a pros and cons and put it in a single sheet? Like, can we make a Google Sheet version of this? And as you take notes, Hyman or Danny, can you please update the columns and so that everybody's seeing it. We do it live.
Yes. Maybe Danny, maybe can you share the screen because my PC is a bit unstable, the network.
Okay, maybe
Okay.
Danny. Okay.
I will share a
Yeah.
screen.
So just make a Google Sheets and then Hyman go. You can go on your 4G is usually the best. This is what I do when I'm just go on your phone, use the
I don't know
4G.
why NTU is so slow.
I even in NTU I use EduRoam. I don't even use NTU to be honest.
What?
Yeah, I use
What's
EduRoam.
happening? I mean, like, yeah, this is this is strange. It's
This is
supposed to be very good
surprising.
internet. Yeah.
Yes. My friend from Huawei told me they spent like millions every 5, 6 years to buy devices.
I see.
And it is so cool.
Let me create a Google Doc.
Okay. Jayanta, what's the question? I did not find the NASB SE2 in the main structure. Yeah. Where did that structure go? Why did you remove it? Okay, we go back to the Google Doc. Let's create a Google Doc first. Should take a few minutes.
Let's create a Google Doc first. Yeah.
Anyway, I think Danny, the classification of made or not made doesn't matter, right? Because you don't need 2 tabs. Because apparently some of these made or no made is made on ICSD, but actually from literature search, many of them, the green ones are already made, right? Just make a single sheet. We don't need to separate it into 2 sheets. Am I right, Havan? Havan's internet is really bad.
I'm just combining everything together.
Yeah, just combine it. It's fine.
What is orange here?
Oh, orange, it means that it has been made and with thermal conductivity report.
Ah, okay, I see.
So okay, the question from Jayanta is what happened to the sodium antimony selenide?
I think Danny
Sodium
did
and
some chemical filtrations which filtered a bit of things out.
because we filled out sodium because that's one of the feedback we get is actually hard to synthesize sodium.
Oh, I think we can put it back. We're doing
We can put
You
it
sodium.
can
back?
put it back.
Okay.
Potassium and sodium are similar. We're using
Okay,
sodium
then
catalysts.
okay, then I bring back the sodium. Actually, I removed sodium because I was under the impression like we can like it's hard to get sodium precursors.
So we use sodium nitrate, NaNO3, and
Okay.
that's quite easy to put into synthesis. Yeah, NaNO3, exactly. And we're comfortable with them. So we are actually got some experience using them. So that's a good sign.
Okay. Can
In
I
fact, we have
have
I
look, I
I
will look
think
for the
what
sodium, right?
Yeah.
And a sorry, what's the R element?
Yeah.
This one, right? Okay,
Yeah,
I
this
put this back. Yeah,
NASBSE2.
this one.
And another one is what Chen Guang has proposed, the AGYTE2. I don't understand.
AGYTE2.
Yeah, it was also removed. Is there a certain reason because of any?
That's I remember this one is because the since NN actually AGY.
Oh, the synthesis NN is low. Okay.
AG2, right? AG2Y.
No, AGYT2 is a 112.
AGYTE2.
Yeah, but so I mean, this is where we need to think about it, and the
Yeah, this
fact
one.
here we have to use that in general for criteria, even for the generative design, right? Because there's no machine learning here right now. So I mean, I just ran, for example, while we're talking on GPT-5 deep research, uh, feasibility of synthesis of K5Y04. So it produces a bunch of text. I don't know how good this is, right? I will forward this to you. We can easily do this through deep seek and stuff, right?
Yeah.
So we should definitely do that as well because
Oh,
that is more agentic and stuff.
Yes.
okay. So AGT2Y is the reason is basically it has a higher Hall. Uh,
Okay. But
okay. So
yes, yes.
it's E Hall is well, it's not that high. It's 17 milli EV, but it's still like we are using a much stricter. Like we are using 10 milli EV as a filtering criteria.
Okay.
And the sodium, yeah, the sodium antimonide cyanide is basically because of the sodium. Yeah, I put back this too. Yeah,
Okay, so maybe you guys can just go through each compound and make a live comment on the side, pros and cons. And
Can you share the link so
today's
we
job is
can
to
just
filter down to 2 or 3 compounds. That
yes.
is
okay,
final deep dive, and then we can propose 1 or 2 that we want to try next week. Yeah,
yes, share.
I don't know if there's a better way to do this. If you guys have a better way of doing this, let me know. Okay, my guys, yeah, I gotta leave. Okay, sorry. I'll catch up with you guys later.
Yeah.
See.
Do you have a link? You can just post in the group maybe.
Yeah, let me just change the. Okay,
Yeah, cool.
now you guys should be able to access. I need to modify the the rights for you guys to be able to access it. Okay, so now I put back the sodium.
Yeah.
Yeah, I put back the last two, which is Tengguan, Gentas one. So like
Yeah.
then the thing is right now, I mean like let's say like let's just add in 2 columns.
Like pros and cons.
Uh, yes, let's see. Row. Uh, probably like let's rank the things according to pros and cons and also the priority. So which one we want to prioritize. Apparently, like you guys are picking different compounds, right? I mean, and also we have one that has not been synthesized, and then so basically like then it gives us the ideas of which one we should start first if we are doing the actual synthesis.
Sorry,
Thoughts?
one thing I'm finding weird is what is this row just after the green row? BI2SNT4. Did you just add it back or
It's
B
the one that you shared, mid structure with thermal
oh
conductivity.
sure,
No,
sure. Great, great. Okay. Because I didn't notice this one. Sure, thank you. My bad.
it's well, like we can literally remove this one because it's already been
I mean
made.
you can
So let
just
me
highlight this maybe in orange. Yeah.
in orange, right?
Yeah. Yeah, these two rows you can highlight in green, I think, because they should have been made.
It's already been made. Okay.
Yeah, the final two rows should have been made. It's just they lack thermal conductivity measurement.
Orange. No, this
Yeah.
orange. Well, it's a different orange.
Yeah, it doesn't matter. Any sort of green will do. Yeah.
Okay, let me try it. Okay.
Yeah, it looks nice.
Okay, let's use this list. And then, yeah, we have the person actually here. This is Janta and Chen Guang. Yeah.
Yeah, so
New.
so
Okay, probably we need to connect to
yeah, so I think we need to have a few standard. So first is we need like say DJS compatibility, whether this material is compatible with DJS because that's the thing we want to try first, right? DJS compatibility.
So anything like that is so this is easy, right? So this is no.
No.
This is yes.
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 Yes. Yes. Should be yes.
Anything with
No.
oxide, basically.
Yeah.
It's more
Yeah.
like this is more like screening for oxide or chloride, this kind of thing.
Yes. Yeah. So, so this is the question to Chengguang and Janta. So how do you actually decide the most compound you want to go with in all the chalcogenides? Because you can see they're all chalcogenides. What's your criteria?
Basically, like
What?
if Chengguang and Janta, if you're gonna put a priority, like how would you rank this priority here?
Oh, but it's nothing critical, right? Can I ask you a question? So if you are going to make, say, this K2 as an TE5, how do you make the precursor? You use pure potassium? Uh, okay, I got what you mean. Sure, sure. Makes sense. Yeah, I think the white one is just a special one because it's the only one not made.
Mm-hmm.
But
The
now
last
the
two also
question is
last two are also made, right?
AGYTE2, I know this phase has been made. Yes, it's reported. It's just
Mm.
the original file, original reference, you cannot find it. It's in France.
Okay.
It's in French and a printed thing, so you cannot find it online.
Oh, really? Okay. So also,
Yes, it's a very old thing. In a lot of databases, you can find so it's basically a high temperature phase of an ordinary AgYTE2. It's very similar to what Chengguang is doing now. Chengguang is doing like AgSBT2, right?
I see. But then, like, how do you exactly classify this thing has been made or not? Like, because like in the materials project, they actually has a dedicated Swiss group, right? Which is like
I mean, no.
156.
I mean, it's easy. If you go to PDF, database, you download the CIF and you compare
Mm.
whether the CIF are the same.
Okay. So the
I
ABC,
mean,
alpha,
this
beta,
makes sense.
gamma, similar,
Yes,
and then
yeah,
okay,
yeah,
Wyckoff sites are similar.
yeah.
I see. I see.
The only thing is this AGYT2, the original reference is lost. So you don't really know how these guys made it.
I see.
Any other criteria we should think of? So we prioritize tellurides, then we have PR, PRTE, KSNTE, and AGYTE. We only have three left over.
I think what we can do is basically like let's make a sort of like voting. Basically, like, you guys can access this sheet now, right? So what I think what we can do is basically like everyone make a vote of like what you want to synthesize, and eventually because we can't synthesize everything, it's more like we see like which compounds has the highest score, and then we sort of convert onto like one or two compounds. Aside from this,
Or maybe how about just do this? We make a few scores. Say DJS compatibility. If it is Y, it gains one score. If it is N, it loses one score. And we have a lattice, thermal conductivity. So the ones with lowest thermal conductivity will prioritize the synthesis. I'm not sure if it makes sense to you. And I think the synthesizability ones are already done. But still, we need to like have like the pros and cons. And pros and cons, we can be slightly more specific here. It can be like whether we think we are able to make this compound in lab or not. Although these green items, they are reference showing that they have been made. So maybe we can have another column that whether we think we are able to make it or not in lab. But it's just some preliminary ideas. But what I'm trying to say is we need to have come with a few columns, maybe synthesis with maybe thermal conductivity, maybe competing phase, maybe phase purity, easiness of processing, etc. Like a standard, and each of them we mark like 1, 2, 3, 4, 5 or something like that. So then we can combine and make a ranking. I'm not sure if it makes sense for you guys.
Well, makes sense to me. We'll be able actually have. I think you have the most experience like in actually doing. Will you be able to actually create the columns, and then we actually follow like the columns you created, and then we can start ranking these things.
Yeah, I think it's a good idea. I can try to create some of the columns, and maybe so if there is anything, I will also add a note. So if there is anything that doesn't covered by the columns, we can always adjust. And finally, after like 1 or 2 iterations, quickly we finalize the columns with the markings, and then we just mark everything. Does that make sense?
Yeah, makes sense.
And for the marking, there was one question. So because there are so many compounds, and so each of us should give a marking, or how does it happen?
Uh, then in this case, I would say just if we sort of everyone agrees upon on the marking criteria, then we can just have one, right?
We
A
just have one,
combined,
so
yeah,
a combined one.
a combined one, yeah.
Then in this case, so how about we still, like Kira said, we write the pros and cons first as the text, and then maybe we meet shortly, maybe next Monday or maybe tomorrow, online again. So we from all the text, then we mark them. I mean, I think this makes a bit more sense, right?
Yeah, so, yeah, that sounds good.
Yeah, yeah, or it's very difficult to align standard or like within us.
Yeah.
Then
Okay.
I will just
So
write whatever I know on the list.
yes,
Yes.
and yeah, and for the rest of the team who is on the call, like you are able to, if you see the link in the WhatsApp, can you check if you can access and edit this table? Should be okay, right?
Yes, I can.
Okay, cool. Yeah, just put your input and also like the column. If you say have made certain columns and then like you think that's what's adding in because of the experimental compatibility, things like that, just add it and then we discuss again. Let's see, probably sometime end of this week.
Yeah. Yeah, we're just
Okay.
adding everything first, and maybe we can just copy things to GPT.
Cool.
Sorry, one thing. The list is shared to me in view only mode. Oh,
View
I will
mode.
request edit. Okay, I will request edit.
Okay. No worry.